Hello, everyone, and on behalf of Telit, welcome to this live webinar. I'm Joe Braga, Head of Regional Marketing, and I'm delighted to be your moderator for today's event. Over the next 20 minutes or so, we're going to explore the topic of uplink interband carrier aggregation and how to maximize uplink speeds and performance, as well as look at some use cases and product design tips. But before we start, I'd like to introduce you to our panel today. First, Marco Stracuzzi, Telit's Head of Product Marketing out of our Trieste office. Marco?
Hi, Joe. Hi, everybody. Happy to be here with you today.
Thank you, Marco. Next, Safi Khan, Telit's Regional Product Marketing Director out of our San Diego office.
Hi, Joe, and hello, everyone. I'm very happy to be here as well.
Thank you, Safi. And finally, Roberto Pogano, Telit's Cellular Product Manager, also out of our Trieste office. Hello, Roberto.
Hello, Joe. Hello, everybody. I'm very happy to be here tonight.
Hey, thank you, Roberto. So let's go to a round of questions here. We'll take some from the audience at the tail end of the event, but let me start with one for Marco. Why is it that upload performance is becoming more important, Marco, for today's cellular broadband applications?
Yeah, right. So the thing is, with the increased production and distribution of data-heavy content and the growing use of cloud services, higher upload speeds are becoming more and more of a necessity. On top of that, Internet of Things, so devices, objects, sending data to the network, are making the need for fast uplink speeds even stronger. I think we need to reverse the traditional logic of thinking about connectivity as the download path only, so downloading content from the network with ADSL at home or with cellular technology on our smartphones. To give you some examples, uplink throughput, that is the amount of data you are able to send, to transmit in a given second from the device to the network, is becoming essential for many use cases. One that I want to start with, very important for enterprises, is branch office networking. So LTE provides a simple, quick, and inexpensive solution to set up internet connection at a branch office or at a temporary store. In fact, it requires a minimal setup. The operator turns the LTE branch router on, and it starts providing reliable and flexible connectivity to the branch office with advanced features like software-defined wide area network functionality. So then the question is, what branch offices do with uplink speed? Well, think, for example, about virtual real-time communication with clients or colleagues using multi-point video conferencing systems. To ensure a smooth communication in both the ways, you need to have high downlink and uplink speed, especially when it's about video. And let me say that these days, it's not only about your workplace, it's also about most of us being required to work from home. And so telepresence is even more important, and you require uplink performance for it. Another important use case for companies is file storage and backup, as well as online file synchronization, because most of companies use cloud services for it. And so you need uplink speed to make it working in an efficient way. Another big use case I want to mention about upload speed is definitely video broadcast. The quality and the definition of video, and as a consequence, the size of video files, has increased over the past few years, and this process has not stopped. So LTE and 5G are the best technologies to give wireless broadband connectivity, for example, to a wireless camera streaming a live event at a stadium, but also to for example, think about a security camera that needs to monitor a location 24/7. So cellular is really able to provide flexible and smooth video stream without interruption for those applications. If you think again about these days where we live in, where we are most of us working from home, also our kids are at home, and most of them are attending online classrooms. And this is another use case where you need to be supported by both download and upload speed to make the two-way communication efficient and to make the e-learning as similar as possible to face-to-face learning. So I'd like to mention other couple of use cases that I believe are very important. One is critical services for the population like telehealth, so sending radiological scans, images, videos to a medical center. This requires a strong uplink performance. The same goes for emergency management situation. So in the unfortunate case of disaster management, rescuers that are on site, they often need to upload high-definition images or video to the control center. And the only way for them to do that is to be equipped with wireless devices, cellular devices, with high uplink speeds. A similar case is about first responders. Think about law enforcement vehicles uploading images and video streams from a crime scene. And talking about vehicles, an important point I haven't touched upon yet is mobility. So if a vehicle is moving or a person is moving around and you need to give connectivity, then cellular is really the best solution to do it. So as you can see, I can talk forever about use cases, but the really important thing is that there is a wide variety of use cases that can be served by uplink speeds and across multiple different verticals. And again, if it has to be wireless, if it has to be in mobility, then it has to be cellular. And to conclude, the techniques that cellular technologies like LTE Advanced and 5G have to provide a high performance both in downlink and uplink are mainly three. One is efficient modulation schemes to encode the data before you transmit it over the air. The second is the use of multiple antennas, but this is not always possible on the device side. And the third one, which is the one we really want to elaborate on today, is the aggregation of multiple radio channels, so-called carriers, that are chunks of radio spectrum owned by the operators, often non-contiguous, that enables the operator to really increase the data rate with the spectrum they have available. And back to you, Joe, to continue discussing the carrier aggregation.
Thank you, Marco. That was very, very good, very enlightening. But keeping on that topic, of course, of the carrier aggregation, I'd like to invite Safi then to dive a little bit deeper into the technical details, and what does it mean, for the particularly for the landscape of mobile network operators. This difference between intraband and interband uplink carrier aggregation, as we consider the need for the uplink high speeds that Marco described. Safi,
Sure.
Can you take us through a journey on about that?
Yes, Joe, absolutely. So I think in order to properly explain the difference, let's first briefly understand how frequency spectrum is allocated. Let's take an example of North America to start with. So when the FCC allocates cellular spectrum licenses, they use a process of auctions, And then the major mobile network operators, or MNOs, like Verizon, AT&T, T-Mobile, they spend billions of dollars to win this highly coveted commodity. The importance of spectrum is very well understood in the cellular industry. After the auction ends, these MNOs, they own pieces of this spectrum in which they can deploy their LTE networks, for example, a gigabit LTE network. However, in most cases, the frequencies that they won during the auction are not contiguous or not next to each other. These chunks consist of separate frequency bands, and that's just how the way it is. The auction process works, and it is sometimes difficult or impossible for the MNOs to consolidate all of their spectrum holdings into one contiguous wide band. So the wider the band, the faster the data rate through carrier aggregation that we will get to. And so basically, in order to deploy a high-speed 4G LTE network, they need some other tricks. So now that we understand the spectrum, let's talk about carrier aggregation, which is one of the three things that Marco mentioned. Carrier aggregation is a means to combine different parts of the frequency spectrum for a given MNO to allow a broader bandwidth for transmission of the wireless signal. Carrier aggregation is one of the primary technologies needed to achieve the gigabit speeds of 4G LTE networks. And this high-speed uplink that's necessary for the use cases that also Marco talked about. So let's go a little deeper. There are two types of carrier aggregation. One is called intra-band, or within the same band, and the other is called interband, or across different bands. So intra-band, or within the same band, carrier aggregation refers to combining the component carriers inside the same frequency band, whereas interband carrier aggregation refers to combining component carriers from different frequency bands. So these two techniques are similar in naming, but there's a big difference. The likelihood of owning a wide amount of spectrum in the same frequency band but the same MNO is low, whereas the more likely scenario is that the MNOs need interband carrier aggregation. The major MNOs in North America, they do not own contiguous spectrum in the same band to support intra-band carrier aggregation. They own spectrum in different frequency bands. Therefore, they rely on interband carrier aggregation, especially in the uplink, to truly achieve 150 megabits per second speeds in realistic deployments of their networks across the country. It is harder to implement interband carrier aggregation in an LTE data card than it is to implement intra-band carrier aggregation. Why? Well, in order to implement interband carrier aggregation, there are certain additional hardware components that are required in the device to combine the signals from two different frequency bands simultaneously in order to get the aggregation effect. These extra components in the device are power amplifiers, could be envelope trackers, filters, RF switches, etc. On top of that, in addition, the data card design needs to be customized for high performance by making sure that you mitigate any interference issues that arise. Now, there are modules from other vendors, but they can only achieve intra-band uplink carrier aggregation today because they lack the necessary extra components that were required for interband carrier aggregation support. They only have a single frequency that can be tuned to at any given time for uplink transmission, and respectively a single power amplifier instead of two PAs. This limitation in other modules, it makes them suboptimal candidates for products that need high-speed uplink to address the use cases outlined above. Now, Telit has many years of experience in designing high quality and high performance modules and data cards. we carefully choose the key product features that target the markets and use cases that help our customers achieve success. One such example is our LM960A18. This is the only gigabit LTE class module that supports interband carrier aggregation in uplink. It is also the only module that is certified on all major MNOs in North America and also beyond, because it is a global module in a single SKU and is ideal for enterprise applications. So I hope that that's enough to kind of get a basic understanding of interband uplink CA. And back to you, Joe, for further discussion.
Thank you, Safi. So very insightful. So basically, yeah, we need to be very cautious about selection there. We could be looking at specifications of data sheets and deciding for something that truly won't deliver the speeds. And but so that takes us actually, it's a good segue into the next section here with Roberto, because now that we've seen the complexities and how we can establish a full 150 megabit per second upload speed with carrier aggregation. Let's hear from Roberto a little bit about what, from the perspective of the design engineer and the integrator, how does designing in these devices need to be taken into account for the end product perspective. Roberto.
Thank you, Joe. Yes, as you mentioned, the LM960A18 is a very versatile and powerful device which covers LTE frequency bands starting from 700 megahertz all the way up to over 3.5 gigahertz. Well, this is imposing very challenging design specifications to the engineers developing the product. We implemented 3 RF chains to cover the high, mid, and low frequency bands and have optimal RF performance. Now, if we go back to what Safi mentioned about carrier aggregation, in some uplink carrier aggregation cases, one power amplifier is operating in a low band and the other one is operating in a high band. And these 2 RF signals can be routed to different antennas. The device, by the way, has different antenna ports depending on frequency band. Now, in cases such as this, the high band receive frequency can be very close to the third harmonic of the low band transmit frequency. And this is imposing very stiff requirements on component isolation, linearity, filter, and duplexer rejection. So this is definitely one of the major challenges when designing such a product. In general, we can say that uplink carrier aggregation requires additional power amplifiers. Let's take a case where you have an uplink carrier on band 1 and another uplink carrier on band 3. Then you would need a second mid-band PA, and this would be probably connected to the diversity antenna and would require an additional switch, a duplexer, and some filtering to protect the diversity receive chain. When we come to customer device design, well, antenna choice and physical placement are extremely important factors. Not only you have to choose antennas which are high performance and wideband, but you also have to be very careful on how these antennas are placed. In particular, the LM960, as I mentioned, supports 4x4 MIMO, so there are 4 antenna ports available on the device for downlink. And of course, 2 of these antennas are used for uplink. These antennas must be, as I said, carefully placed to avoid any unwanted interaction between the antennas themselves. Moreover, devices such as broadband cellular routers are often employing other RF technologies other than the cellular technology. For example, GNSS or Wi-Fi. This means that there are additional antennas for those technologies. And this makes coexistence problems more likely to occur. There are other challenges when you come to the design of a device embedding such a powerful data card. For example, current consumption. The LM960 peak current consumption is way higher than your average cellular module. So the power supply must be carefully chosen and designed in. Last but not least, heat. Heat dissipation must be properly taken into account to avoid that the data card overheats and falls into thermal protection mode. Now, to overcome all these challenges, Telit Application Engineering is prepared to offer design suggestions to our customers to support them in all aspects, from the early device design, component selection, all the way to certification. Back to you, Joe.
Thank you, Roberto. That was very, very insightful. And so we've heard a lot of good information here about the importance of uplink speed and how we can achieve it with gigabit LTE card. For you, Marco, what is the bottom line for this discussion? What's a good takeaway for our audience today?
Yeah, thank you, Joe. I think if I can ask those who are listening us today to remember a couple of key messages from our discussion. The first one is too many times I've seen that when evaluating the performance of a cellular product, the focus is only on the peak download performance, while it's important that you are taking into account upload speeds as well when considering the connectivity needs of your business. As we discussed before, investing in upload speeds and not only in download speeds has benefits that can be felt across many industries and scenarios. And cellular gigabit LTE and 5G delivered by Telit data cards can provide best-in-class upload speeds so that your business application and communication can perform at their best. The second takeaway is not all cellular modems are made equal. So you need to carefully check if the product you select can support the right advanced features you need. In fact, as Safi very clearly described, claiming uplink carrier aggregation support is not enough. What you need to look for is interband uplink carrier aggregation, because that's the only features that really enables your application to reach the highest peak throughput in realistic deployments, and not only on the datasheet on the paper, which is nice, but doesn't really help in real life scenarios. And this is not trivial. So Roberto covered it pretty well. There are a lot of design challenges on the module and also in the application to make sure you can support interband uplink carrier aggregation. But at the end of the day, this is really how you can get to a not optimal performance. So hope in a nutshell, this summarized what we just discussed before, Joe.
Thank you, Marco. Very, very well summarized. So we have a little bit of time for a few audience questions here. I'd like to get one here for Roberto. What are the peak uplink speeds that 4G and 5G Telit data cards can reach?
Yes, interesting question. Well, in case of the LM960A18, which is an LTE Cat 18, category 18 data card, the maximum uplink throughput is 150 megabit per second using dual uplink carrier aggregation. Can be intra or interband. So bottom line, 150 megabit. But we can go even further. The new 5G data card from Telit, the FN980M, can reach up to 211 megabit per second in upload with LTE, and in 5G with a combination of 2 layers in LTE and 256 QAM modulation, plus 800 megahertz bandwidth in 5G millimeter wave. also with 256 QAM modulation, the maximum throughput is 211 megabit per second. So that's quite a bandwidth if you consider this as a mobile device.
Joe, I think you meant gigabits per second there, right?
Yes.
Sorry. Oh, shall I repeat it?
No, that was good. I think that's still very clear. Thank you, Roberto.
Yeah, so 2.7 gigabit per second is the maximum throughput of the 5G one.
Oh, the 5G, yes.
Yeah.
But this is an interesting question coming from an audience member here in the U.S. And I'll direct this to Safi. Can you give us some examples of typical interband uplink carrier aggregation combinations for North America?
Yes, sure, Joe. So let's take an example of Verizon first. As we may know, Verizon owns a spectrum in bands 2, 4, and 13. Now, these are different frequency bands. So our module can combine bands 2 and 13, and it can also combine bands 4 with band 13. So these two carrier uplink carrier aggregation combinations are possible for Verizon. Similarly, AT&T and T-Mobile own a spectrum in bands 2, bands 4, band 5, band 12, and band 66. So as you can see, again, this is going back to what we said earlier, that the spectrum is owned in multiple different bands. So our module for T-Mobile and AT&T can combine bands 2 and 5, 2 and 12, bands 4 and 12, and also band 5 and 66. So these are some great examples of how we can really address all carrier requirements of uplink carrier aggregation. Beyond this, as I said, the module is a global SKU. So we also have many more uplink CA or carrier aggregation combinations, which are for other global MNOs. And you can find the full list of those in our hardware user guide, which is available at telit.com. Back to you, Joe.
Yeah, thank you, Safi. Yeah, that's actually a good segue for this other audience question here. I think Marco's best suited to answer that. What about uplink carrier aggregation combinations for the European MNOs?
Yeah. Thanks. That's a valid point. So most of European operators are exactly in the same situation that Safi just described for US operators. So in general, it is unlikely that an operator can get from the public auctions big chunks of spectrum that are next to each other in the same 3GPP band. So most of the time, they own multiple radio channels of the spectrum in different bands. And so conclusion also for European operators is paramount to support interband uplink carrier aggregation to really enable the devices to reach the peak uplink speed in real field deployments.
Very good. Thank you, Marco. Yeah. And one last question here, a pretty inevitable question, after so much information is shared like this, how can I get my hands on and experience the speeds of the LM960 data card? Maybe I'll let Safi take that one.
Sure, yes. We have a link in a resource section of this event where you will be able to click on a link to take you to a website from telit.com, and over there you can fill out a form and contact our sales team, and you'll get access to a complete evaluation system for the LM960 A18, and then you can easily follow the instructions included and basically power up the module data card and connect to a network. And then you can basically run a simple speed test to check your connection speed. It will give you both downlink and uplink directions.
Very good. Yeah, we're looking forward to hearing from you all on this, and I think this is all the time we have for today. I wanted to thank our panelists and absolutely thank you all for joining us today. Again, we're available. There are some additional questions we couldn't get to. We will be in touch, and we'll be in contact with everybody else that we didn't get to. Thank you again. Have a great day. Thank you from all of us at Telit. Thanks.